we're going to determine whether or not the triangle below is actually a right triangle. So this angle over here in the left corner looks like it might be 90 degrees, but we can't say for sure. It's not drawn to scale. There's no box that indicates a right angle. And so we can't assume things. We're going to have to actually prove it. And we're going to do that by using the converse of the Pythagorean theorem. So as a reminder, the Pythagorean theorem says that if we do have a right triangle, so this triangle here is a right triangle given this symbol, then a squared plus b squared equals c squared. So if I had the lengths of two of the sides, I could find a third one. We're going to use the converse of this, and we're going to say, okay, if I have all three of the sides, so let's say I knew that a was 3, b was 4, and c was 5. If I took those three lengths and I substituted them into the formula, if it makes it true, if it makes the equation true, then I have a right triangle. So the important thing is that we substitute correctly. So remember that c is the hypotenuse of the right triangle. It's the longest side, and it's the side that's across from the right angle. The A and B are the legs. An easy way to remember this is that if you think about the letter L for the word legs, the L looks like a 90-degree angle. So the legs are the two sides that make a 90-degree angle. So I see in this picture, the A and B make that 90-degree angle here in the corner. Okay, so if I substitute incorrectly, my C, the hypotenuse, in this example is 5. So I'm going to replace that with 5 and bring down the exponent of 2. My A and B are interchangeable, so it doesn't matter if I write 3 squared plus 4 squared or 4 squared plus 3 squared, they're the same. So I will write 3 squared plus 4 squared. All right, now we're going to go ahead and solve. So 3 squared is 9, 4 squared is 16, and 5 squared is 25. Nothing to do on the right side, but on the left side, I can still add. When I add those up, I get 25. And so I have 25 equals 25. I have a true statement. So what this proves is that because I took the three lengths that were given to me in this triangle, and those three lengths made the Pythagorean theorem true, that means that this triangle is a right triangle. So let's do it with the one that I initially showed you. I have a triangle. I'm trying to figure out if it's a right triangle. So I'm writing down the Pythagorean theorem, a squared plus b squared equals c squared, and I'm going to make sure I substitute correctly. So remember, C is the hypotenuse, which is the longest side of a right triangle. So if this was a right triangle, the 12 would be my hypotenuse because it's the longest side. So I'm going to replace the C with 12 and bring down that exponent of 2. The A and the B are the legs. Again, interchangeable. It doesn't matter. So I have 6 and 8 as my legs, and I can write down 6 squared plus 8 squared or the other way around. All right, let's evaluate. 6 squared is 36. 8 squared is 64. And 12 squared is 144. 36 plus 64 is 100. So I have 100 equals 144. And this is not true. So when I substituted these three lengths into the Pythagorean theorem, I did not get a true statement. And what that means is that this is not a right triangle.